And I'm just going to do a little muting here. If you want to speak, you're absolutely welcome to unmute yourself and ask questions or ask them in the chat. I'm going to basically have two computers set up. So I'm speaking to my Mac, and then I'm projecting from my Surface so that I can kind of annotate the screen and talk about, kind of have that live whiteboard set up. But where's my pen? Rather my stylus. Oh, there it is. So discombobulated by this time of the semester. All right, so let's first just take a look at Canvas and see how I kind of organized our work for today. So on Canvas, if you go to the modules section, you have a module for all the different weeks, and we're going to go down to class 8, which is this class, and we're looking at a few different things. So a lot of the slides I have already posted here. So if you can either follow them on the screen share, you can take a look at them yourself. The way that these, there's really kind of 3 quizzes that are associated with today's participation. That's the kind of post-college options quiz, the scavenger hunt, looking for kind of pieces of data from the Bureau of Labor Statistics. And then there's, we're going to do this section on ethics. And there's a film to watch. It's about 20 minutes, I think, I think it's in the 20s. And it presents like a nice ethical dilemma, and there's kind of like not a lot of clear answers. So it allows you to kind of think about it, and that's going to be wrapped up in this quiz. And then there's an assignment on ethics. So although there's quite a few things there, those quizzes are pretty straightforward. And by the end of this class, I would expect that you've already done them and marked the answers as we finish up today. I wanted to introduce this project, the Mobile project. It's a project that we've generally done in this class. And when we do it in person, we have this opportunity to see each other's mobiles in 3 dimensions in the classroom space, and they're moving and such. So we're going to be kind of denied that. But there's a lot of little aspects of engineering that we want to cover, and this project covers them. So the project was really inspired by an artist and an engineer named Alexander Calder. And he makes these really amazing mobiles. This mobile that you're seeing here, without being able to see it moving, right, it doesn't really do it justice. So we'll pull up a video in just a second to take a look at how the mobile moves in 3 dimensions. But the main idea here is that, let's look at this project description. So you want to design and build a mobile that represents you and your interests. So in terms of the things that are hanging from it, the different items, those will probably be somehow associated with your life. So you can pick them from stuff that you have around. You want to have these 4 different horizontal supports. So, a mobile has horizontal supports, and it's all based on this idea of balance. And that's about what we call static equilibrium in engineering. And there's a whole class on statics. It's called statics, but it's on static equilibrium and static analysis. And that's followed by another class called strength of materials, and then another class called dynamics, which is about things and analysis of forces and things that are moving and going through different kinds of movement. So we're going to analyze this mobile as a static structure. And that has to do with the balance of like, how much do you hang here and how much do you hang here, and how do you get it to balance in between? But you're supposed to have 4 independent horizontals. It must ultimately only be supported by 1 string. So its ultimate attachment to something will just be through a single string. And no horizontal should be supported in the center. So if you have items of different masses or different weights, then it naturally won't balance in the center. So think about that when you're going through it. And then you're going to create this report. So the report would be a title page. You know, you kind of want to have it as a report where the front page looks like the front of a book or something. It has your title, it includes your name, the date. Then you're going to want to include some photos of your completed mobile. So you are you're required to build this in real life. And there's two different ways you can kind of build this. You can sort of draw it and design it on paper first, and then try to build to your drawing. Or you can build it in real life first and then make sure your drawings and your report represent what you actually built. And you could do it either way. And there's challenges and benefits from doing it either way. So ultimately, you're going to write this little report. It's going to have photos of the mobile. It's going to have a discussion of like why the items you chose were important to you. And then it kind of has the engineering part, which is the sketch and the part numbers and the parts list. So if I go ahead and look at that example, let's open that up. You'll see that, you know, here is a kind of engineering type sketch of a mobile. I am going to actually open this using a tool that allows me to draw on it. Perhaps, maybe not. It refuses. All right. I insist. So when I talk about a horizontal, right, that is like this. This is a horizontal, one of these sticks. And this could be in real life, it could be something that is uniform, like a dowel, a piece of wood. It could be a piece of bamboo. It could be a branch off a stick. It could be a hanger. It could be, heck, it could be a baseball bat. It could be anything that kind of sets that structure up, right? So you have a horizontal and then you have things balanced off it. So here we have 1, 2, 3, and 4. And so the idea here is that we want to have 4 different horizontals. That's the goal. And you can see that, you know, when you go down in a mobile, what, you know, that top horizontal is balanced by this horizontal and this horizontal. So there's no objects directly attached to this one, but you can design it however you want. You could have an object on one side and all of the horizontals coming off the other side. It's really up to you to decide. And then you want to use this numbering system where for number 5 here, you see down here on the part list, we have a 5 and it tells us that that's a widget. And a widget is sort of like just, you know, it's a thing. It wasn't really identified. But you can see over here, this one, that was actually a tape measure. You have keys over here and number 7. And so the idea is that you're just going to build sort of this, what's called a bill of materials. That's what this part list and part number thing is. If we look at the kind of documentation that engineers make, you know, they end up kind of giving lots of different views of how something is put together. So you've probably seen, let's go to the web, just quickly jump out. For something called an assembly drawing. And, you know, if I go to look at images, for example, you see like all sorts of these kinds of drawings for engineering objects, right? So this one's kind of relatively simple, I would say. You can see it's showing you all the parts, where the bolts are, all the dimensions. So you've certainly well, I'm assuming that you've seen these kinds of diagrams when you've maybe bought furniture, or bought a, gotten something. But this kind of drawing is called an assembly drawing, and it basically shows how the individual parts fit together into a whole. So a lot of what you're designing when you work on your mobile is you're kind of showing how the individual parts fit together into a whole. And so that's the goal of this part of the assignment. Let's jump back to the project definition. And, so down here is the rubric. That's where your points are all earned. And then, the rubric down here. So you want to pay attention to that. But let's take a look at this mobile. This is a time lapse. So you'll see that it has a really kind of amazing, slow, like evolved movement. And part of the challenge of building a mobile is that it should never tangle into itself, right? And that's one of the challenges that people, that you will find, not just people, but you as people will find that it's harder than you think to create something where no matter how the things independently turn, they never collide, they never have a kind of crash. So yeah, just this like I said, the he's known for the like his subtlety and the beauty of his mobiles and how they move. Any questions about this project? So the project is due on the last day of class, and that, as you probably know, is not the end of the semester, but is November 12th, right? So we wanted to give you a heads up for this so that you could start working on it and get, start collecting stuff and get it all assembled. And so I just kind of want to, it's not due next week, it's due on November 12th, but you have a little bit of time to think about it. Any questions about this assignment? Okay. Well, if anything comes up, just let us know and we will try to address it. Okay, so let's go back to my agenda. Let's talk a little bit about this split between engineering and engineering technology. Does anybody have an idea of how those two different fields differ? I was trying to freak you out that I had frozen, but I'm actually live. All right, no one has any idea how they're different. That's fair. That's why you're here, so I can talk about it. So let's make a new page and we'll start building a little list of how these two fields are kind of different. So on this side, I'm going to go ahead and put engineering. And put engineering technology over here. And I think like from a kind of student perspective, the two biggest things to realize between these two fields is that engineering tends to be more of a theoretical field. Now, it may not be as theoretical as like particle physics, but it has a large theoretical conceptual knowledge base that's required to be successful in it, where engineering technology tends to be more practical. And so one of the things that comes out of this is that the theoretical nature of engineering leads to a lot of calculus based classes. And the kind of practical notion or nature of engineering technology really leads it to be more based on algebra, trigonometry, and statistics. Right, so the barrier of entry to these two fields is different. So as you're looking at, schooling, and you kind of are planning your future, for some people, you'll be interested and fascinated by the technical part, the kind of theoretical parts, and, calculus and the math and how that describes the future. And other people may have more of an affinity for the practical nature, like working in a lab, like working in a shop, kind of putting, getting from an idea to the nuts and bolts of how it's actually completed. And the math required for those two fields is a little different. Tends to have different degrees, right? So an engineer generally has a bachelor's degree. And in fact, when I say they have at least a bachelor's degree is what I should say, because it's sort of a requirement of being an engineer. And engineering tech, oftentimes it's specific to fields. And so it's more associated with associate's degrees, right? And the big difference in these is that, bachelor's degree is a 4-year degree. That just means that if you were considered a full-time student, you could probably finish it in 4 years, where an associate's degree is a 2-year degree. So the way you should think about that is, there's kind of half as much coursework required for one than the other. So it's, if you're looking to get out into the workforce sooner, that's a real concern of people, and that's something legitimate. So that might be another reason why you would choose one over the other. The kind of engineering technology side tends to have, in addition to associate's degrees, they might have certificates that are associated with skills in that. So if you wanted to be a computer networking technician, you might have certificates from, say, Cisco and their router technology and exactly how to program their routers, not the abstract idea of what is a router, how does a router work, but the concrete nuts and bolts of, like, how does this router work? How do I connect two of these kinds of routers? How do I connect this kind of router to another kind of router, right? And that's that kind of practical idea versus the kind of theoretical idea of what is routing? How does a network work? What are bits and all that kind of stuff, which is important. And I'm kind of like making blah, 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 but, I have that personal interest. Like, I'm a pretty theoretical person. But I do like to mix it with the practical, right? So there's ways for you to kind of work in either place, but it's something to just note about your personality and what you like to do. And, over here in engineering, if you want to advance, you probably wouldn't be seeking certificates. You might look for advanced degrees. And that would be things like a master's degree, or a PhD, or you might follow through and try to get professional licensure. Shun. So for example, if you want to be a civil engineer and actually be able to design buildings that are actually built, you have to be licensed to work as a civil engineer and licensed to understand structures and how they respond in earthquakes. And you require a stamp, and that stamp, it comes with this professional licensing. So that's, kind of part of the difference between the two degrees. And we always like to share that with our students, Engineering 5 students, because, your interest in why you ended up in this class doesn't mean you're all on the exact same path. You have a lot of like personal choice, a lot of personal experience that may lead you one way or the other, or personal interests that just lead you one way or the other. The one other thing I will share on here is a nice little graphic I found on the ASME, the American Society for Mechanical Engineers site. So I'll copy that and put that over here in these notes. And it's a little graphic that basically tries to show how these two different, kind of degrees, how they work out in the real world. So you'll find that if you look from the left-hand side, which tends to be more of the engineering tech side, versus the right-hand side, which tends to be more the, the engineering or the theoretical part. On one side, you have theoretical research, and the other side, you have distribution and sales. Both of those are super important and valuable skills and things that engineering organizations do, but they tend to like be pretty polarized to the different degrees. Whereas you move into the center, like company management, component design, test evaluation, there's a lot more kind of overlap in those regions of the industry where it doesn't, it's more like how you fit into your company and how your skills evolve than whether you're like, oh, that's only for engineers or that's only for engineering technicians. There's overlap. And so I thought this was a nice kind of graphic to show that, you have a lot of mobility no matter which route you take. And so you can, as an engineer, move to the more of the practical aspects of, testing, components, manufacturing, production, and not just like out in the research, like nothing we invent will ever be made, or it may not ever be made. It's looking out 5, 10, 15 years in the future. So those are just all things that, are available to you in either field. And it just kind of depends on how your career evolves. Any questions about this idea? Any comments or concerns or other like aspects that you want to try to explore in today's class before we move on? All right. I think that was nothing. Oh, wait, we have a question. Is it possible to get promoted to an engineer job title after many years as a tech? The title, maybe. In other words, you may be able to work in a company under the job title engineer. You cannot, that does not give you the degree, nor does it allow you to transfer as an engineer to another company. So for example, my wife worked in the tech industry for about 13 years at one company, and she was hired as an engineer. Her title was engineer. She didn't have the paper degree. And so when it came time for her to find jobs, it was more difficult because she didn't have the degree behind the title. So the people that she worked with could attest to her skills, and you could go through, like you could use LinkedIn and other things to kind of try to make that leap. But ultimately, without the credential, without the capacity, like without the kind of proof, I hate to say proof because it's not that someone that doesn't have a good degree couldn't solve the same problems that someone who has a degree can do, but it's just part of the system. So technically, outside of maybe the way you're paid or the way you're respected in your company, it might be hard to take that pay and respect to another company. Other questions out there? That's a good one. That's an important one because sometimes it creates challenges as you try to shift your position in the company. All right. I think we're planning to have a visitor come in and talk at, let's see, where is it? I think it was 4:30. Is that you, Isadora? Oh yeah, you are. You're here.
Yes.
Awesome. Yeah, this is perfect timing. So let me stop screen sharing. And so I want to introduce Isadora McCullough. She is an engineer working at, oh my gosh, it just
Agilent.
Agilent, yeah, and Agilent is a biotech company, and so she'll just talk a little bit about her experiences, and we'll answer any questions that you have. So
Yes.
let's
And
let her.
sorry I missed it the last time. I can't believe it.
They didn't even know.
Oh, okay, good. Yeah, it's been so October is the end of fiscal year for Agilent, so it's been very chaotic. So my name is Isadora McCullough. I was born and raised in Brazil, moved to California as an exchange student, then ended up coming back for my degree. I went to Cabrillo College. I got my ASs in engineering, science, and chemistry. Took some time off, and then transferred to San Jose State as a chemical engineer. And then while at San Jose State, I decided that I didn't want to be in a lab all the time like I thought I did. And I ended up getting a minor in business. And now I am a biopharma market specialist for Agilent. So I still have my technical life. I still have to use a lot of it, but I am also dealing with tons of people and the sales world, life of things. I still have your questions here, so let me go through them. How did I get interested in engineering? So that was one of the questions. So I actually got interested in chemistry first when I was in high school. And in Brazil, you take a test after you graduate from high school to pass to college. So you decide really early kind of what you want to do. So when I was like a freshman, I was between chemistry and like architecture, but I can't draw for the life of me. I don't know where that came from. And then I was like, oh, chemistry. But then more that I look into it and more that I research, it seemed like you just analyzing the same stuff over and over again. And then engineering was, more creative and different projects, and I could expand my career more. So I decided that I wanted to do that. And I wanted to work for a petroleum company in Brazil. That was my biggest dream. So I got my degree, and that's not what I did. But that was the idea when I was a freshman, sophomore in high school. So my passion for engineering has been, I guess since I was younger. Let's see. What else I have to tell you guys? Oh, I lost the question. Sorry. I try to keep on the questions so I don't talk too much. And then why did I choose my field? So I chose chemical engineering because I really loved chemistry. I never really loved physics. I was bummed that I had to take physics. I loved Carlos, and thank God for him. But physics just wasn't my thing. And chemistry was really fun. I really loved it. So I ended up going with chemical engineering. If I went back today, I would look into maybe like biomedical engineering. Seems like something like that I would open my mind to. But I didn't know much of the engineering role when I decided, and I just stuck to it. I just said chemical engineering, like chemistry, that's what's going to be. Even though when you become a junior and a senior, you don't do a lot of chemistry, but still, I just stuck to it. So I did go to San Jose State University. My experience at Cabrillo, it was definitely different than my experience at university. It was, Cabrillo is a smaller school. Everybody's kind of like that family life, hanging out at Mesa. Everybody knows each other. The commute wasn't bad. I lived in Santa Cruz. It was great. So my experience was good. I really enjoyed. I had a hard time, I would say, finding a female support kind of. So then when I got to San Jose State, I started like a woman in engineering sorority for just girls that are engineers, so I could find like a group of people to hang out with, and that helped my networking, helped me get through school and deal with the stress of being a transfer student. Being a transfer student is definitely different because you show up and people been there since they're freshmen, and you're just trying to find yourself. But I really loved Cabrillo. My classes there were definitely, the professors cared more for me, I would say, than the big classrooms in the university. They were kind of just like, yeah, you're one other person. You have to really, just do your stuff. So my work as an engineer. So like I said, I'm working with sales. So my industry is focused in biopharma, and we sell Agilent sells a bunch of instruments, but my department sells the chromatography instrumentation. So I work mostly with liquid chromatography instruments because that's very popular in the biopharma world, but we also have the gas chromatography, mass packs, and other instruments that we sell. And I work with customers to find what solution they have, so they need. So they call and they're analyzing an aggregation on, on a monoclonal antibody, and I have to talk to them, go through their process, what kind of separation they're doing, what trying to analyze, what they're trying to find, and then we find the correct configuration of the instrument that works for their lab, and then the correct column that they have to use, and we make something to create the perfect workflow for their lab. So I'm most of the time talking to customers, but also learning a lot. I'm constantly having to keep up because biopharma is such a big industry, it's constantly growing. So I have to always keep up with what's happening. COVID happened, so I had to keep up with that, and you have to keep studying. So I think I mentioned that in your last class. I feel like I study sometimes more now than I did in school, because you have to keep very fresh. And in school, you study something and you take the test and you just kind of in that book. But now it's just like there's information everywhere, and I have competitors that I'm going against, and you have to always know the newest technology or the newest solution out there. So I feel like I'm constantly trying to learn and see what's out on the news. So it can be intense, but it's fun. My favorite project that I worked as an engineer, I didn't do much in chemical engineering, very like process engineering. A lot of the people that I graduated with went towards process engineering. I had my senior project, which is very hands-on. We worked on that. I had a few internships, but I didn't do anything very crazy. I kind of went out of that path as soon as I found out I didn't want to be in a lab. I had a bioengineering lab that we would be there till like 10:30 p.m. and it was fun, but it became exhausting, and you can't talk. You got to pay attention to things. And I was like, I really miss people, and they can tell I love to talk. So I was like, I don't know if that's what I want to do. So I started to get jobs more towards sales, technical sales, with the whole technical engineering that some people call under my belt, so I could graduate and have a job. What else? How's my engineering degree impacted my life? As a female, it's amazing to walk around and say I'm an engineer, but impacted me a lot. I think that for some reason people have some different look at you, even though it's just a degree. And I think sometimes if they are not an engineer, they don't realize how much struggle it is and how it's not like we're genius or anything. But there's definitely a different aspect towards things. I think that in my work, people have this idea that I'm good at critical thinking and that I'm a fast learner because of the degree I went through, which I think that's how I ended up getting, my full-time position. I was an intern at Agilent before I got my full-time position. And I think that's a little bit of that. Some of my coworkers have like masters in biology, but not an engineering degree. So sometimes people look towards me expecting me to have some critical thinking or some faster thinking. I also think it helped me just getting paid more. I'm not going to lie. Like, I think that I see some other of my friends that didn't have an engineering degree, and the engineering degree kind of pay more. So that was a nice thing too. But I think it affected in a lot of ways. It's definitely a good thing to have under your belt. And I didn't get a master's. I didn't get a PhD. I know a lot of people end up doing that as well. But yeah, just having a bachelor's, it makes me feel very special. Okay, so what one suggestion do you have for engineering students on their educational path or their career? My suggestion is network. Go to LinkedIn, find people and explore, get out of your comfort zone. I would say that I wouldn't be able to learn about sales engineering if I didn't get off of my comfort zone and explore other things and networked and met other people. I remember the last class of yours, Carl, that I attended, one of your students reached out to me to LinkedIn. And I think that's huge, right? Because now I remember his name and I remember what he's looking for. So in the future, if I see something that reminds me of him, I'll be like, oh, this person went there. So it gets you a lot, really far. Like I got an internship because I met a CEO of a company, of a startup in a conference, and she gave me a job, and I didn't really had an interview or anything. So I think the networking is very important. Use Cabrillo as much as you can, you know, the support system that you have, your classes and everything, take all that you can, and be ready for the big image of the university and how the big classrooms, no much 101 kind of deal. But then when you get there, try to enjoy and sign up for clubs or other networking opportunities. I think that it really impacted my life and how fast I got a job compared to, you know, some of my colleagues and my classmates. So I think that's a really big thing that I would say. Okay. Did I forget anything? Any questions?
I think we're getting close to one.
¿Cuántos años você tinha quando você se mudou acá?
Sorry, say it again. You were cutting.
¿Cuántos años você tinha quando você se mudou acá, a Califórnia?
Eu tinha 17 anos. I was 17 when I moved here.
Okay. And what city are you from in Brazil? Sao Paulo?
No, I'm from Rio de Janeiro.
Okay.
Like Americans say, Rio de Janeiro.
Yeah. eu conheço o Rio.
Yeah, I love it. Did you like it?
Yeah. So you're what's the word? Carioca. Yeah.
Yes.
Cool.
Yeah, I love Brazil. I wish that it wasn't so tough. You know, definitely getting an education in America was my idea of having a better life there. And then a fun fact, I ended up meeting my husband in an engineering 5 class, and I stayed here. You know, years and years ago. So, but yeah, the idea was to go back. I miss home. I go as much as I can. Not now with COVID. I was supposed to be there in the summer, but this whole thing happened. But yeah, it's a great place. If you guys in the line never been, and after this whole is done, make sure you take a trip there. It's a good place.
So other questions out there? I have one, which is,
okay.
It sounds like part of your, I mean, I think it works with your personality is naturally exudes this kind of leadership and grabbing people and getting people to do things, right? And it seems like, I know from my experience in the engineering field that is a pretty rare quality. And I can see why, you know, like taking advantage of things like starting clubs and doing those things, that anything that's within your control at different levels of your kind of college experiences really helps cultivate that, that ownership and that willingness to take on and try to make something happen. And I just want to emphasize to everyone in this class, like, it doesn't always have to look exactly the same. You know, it doesn't always have to be like sort of the get people together, but that idea that what you really want when you're hiring an engineer is someone that if you gave them their own time, like if you gave them time off, they would make something cooler than when you try to tell them what to do. You know, it's kind of that, that internal piece that, of creation and like interest and, you know, how that all fits together. So really don't be shy in that way. Like, have some pride in your ideas and your efforts and recognize that all those things add up to all the times you did something that no one needed you or expected you or asked you to do, but you did it anyway because it was cool to you. Those are the kinds of things that will always be recognized, even if they don't fit exactly in the networking zone or something else. But that thing that was like, wow, what made you make that? It was just like, I just wanted to. And so definitely follow your passions as much as you can within the industry, and where you have that energy and that flow. I know this is really more of a a sermon, I guess, than a question. But is it?
No, I completely
Yeah.
agree with you. I completely agree with you. I think that I do hear that a lot. Oh, you're very like outgoing for an engineer, right? And I think that I was always an outgoing person, and moving here and having English as a second language, I became a little shy of speaking because of the accent and all that stuff, right? And then when I got to San Jose State, I definitely creating the sorority made me more outgoing, right? So I kind of went outside my box, and I came back to this old me that loves to be, in front of people and talking. But that was my passion, right? I'm passionate for people. I'm passionate to meet new people and have conversations. So I totally agree with you. And I think a good example is within the sorority, it's because it's a professional sorority, right? We had a lot of events and resumes and things like that. And I remember the best advice that they give was exactly what you're talking about. Like some students saying, I don't have an internship, or I don't have anything to put it on my resume. And they were saying things just like, your side project that you do because you're passionate for it. Just put that on your resume. I had a friend that her resume had like projects, and she just put all her side projects. She made some robot by herself and she wrote it out. And it's funny because when I got interviewed, a lot of the time people would be like, oh, you started a sorority? Tell me about that. And my friend was like, oh, you made this on your own? Just like you're saying, like people get interested because you're competing with people that also went to school, that got the same degree, right? So it's kind of like, what do you have extra outside of that everybody that's in the class with you did that you did? So yeah, I completely agree. Follow your passion, do things on your free time, like studying is great or whatever, but try to find a free time to find your passion and focus on that, because a company also wants you to be yourself, right? Like the most authentic you are, the more chances you have. And I completely agree.
Other questions out there?
So what are some kind of projects that you're working on right now?
Yeah, so with work, I have few non-engineering projects. I have a project I'm teaching. So because of COVID, we're getting new people into teams. So I became a teacher for new people that are coming in about biopharma. So I have every Friday, I have this like project that I created with a colleague, and we teach the national, the whole United States, anybody that's new to Agilent and is going to be working with the instruments, with the biopharma, and learning about, just workflows within biopharma. I had more before COVID because we had the lab and we get to go and see things, but now I've been working from home since March 6th. So a lot of it is just trying to get this communication to work through webcam. So it's different. I don't have much going on besides trying to help people through the PC.
Any other questions out there? All right, well, let's thank Isadora for coming and sharing her experience with us. And hopefully we'll be calling you guys all in about 5-6 years to come speak to an Engineering 5 class.
Yeah, I know, that's fun. I loved it. Thank you for the invite. It's always, nice to see the engineering. And another fun fact, so my husband and I met Engineering 5. It's upstairs right now in another Engineering 5, which my time we only had one. And I was like, wait, there's another one? So he's over there talking to another Engineer 5. But yeah, it's fun. Keep your connections with Cabrillo. You always come back and get to meet people. If I don't know how many people are looking into chemical engineering or anything that I can, or San Jose State, feel free to find me on the internet to ask me questions or any help you need. I know it's a weird timing. I would say we can go get a drink or have a cup of coffee, but we can do this, just a 101. Feel free to reach out, and good luck with the whole online classes.
Awesome. Thank you.
Of course. Bye. Have a good night.
See you later.
Bye. De nada.
All right, so let's see. Let's go back to sharing my screen. And our agenda. So where are we? Well, we want to talk a little bit now about engineering employment. And I think that I think we've done quite a bit, or at least, you know, like when Preeti and I kind of split up, I don't know everything that happened, but I know that you guys went over and talked about like the different branches of engineering. So I'll create another page here and keep tangling myself in my cables. But, you know, when we talk about branches, we're thinking about things like mechanical engineering, right? Or civil engineering or chemical engineering, materials engineering, etc. Right? So these go on and on. So I know you guys have talked about those and you have some sort of sense for, or hopefully you're starting to gain a sort of sense about how mechanical engineering is different than civil engineering. Then did you guys also talk about the functions of engineering? I think we did cover that. So that would be things like design, research. What were some of the other ones? Does anybody remember any of that stuff? I know someone does. Isadora, right? She was doing sales engineering. Oops. Sales engineering. We have test engineering, management. Let's see, I think something. Oh, safety. Yeah, there was a big list of these. Let's see if there's any that I missed. Consulting, did I get that? No, not yet. Test, oh, development. Analysis. Seems like teaching is in here. That's a role in engineering. And I think entrepreneur is the last one that the book kind of talks about. Have you guys talked about this stuff?
Maybe a little bit.
Okay. Yeah. Okay. Thank you. Because, you know, like when you have multiple teachers or even, gosh, you know, I might have talked about this a couple of times, but I don't want to like just keep talking about the same things, right? So I just wanted to kind of note that once you're in a field like chemical engineering, and then there's all these different functions that you can kind of work as. So you could work in any one of these roles within a company. You could be doing research or you could be doing sales. You could be doing testing or you could be a manager, right? There's like, even though you've chosen mechanical engineering or chemical engineering or civil, there's a lot of variety of different kinds of roles that you could play within a company. And then beyond that, you actually get into that there are different kinds of industries, right? And in this particular case, we're going to look at sort of the difference between large companies. So these would all be like private industries, but large companies. And small companies. So what are some of the things that you will find at a large company? Maybe you could think about these as or cons, but what are some of the differences about working in a big company versus a small company?
A large company
There
might
might be
have
more room for
multiple.
a change.
Okay, so we have more room for change. And what was the other one?
A large company might have like more teams of engineers.
Yeah, so this would be like existing. I'm going to abstract that a little bit and say existing resources. So that could be people, you know, it could be engineers. Engineers are people. I'm not trying to make any differentiation there. You know, sales, all sorts of important parts of running a team that go beyond just, or like selling a product, then go beyond just engineers. So you have these existing resources. This list can go on. It could be, it could be money, right? Large companies tend to have existing money. As we get more items, they might show up there. I think when Clayton, I think that was you, Clayton, you said more kind of room to move, right? There's an
Yeah.
existing hierarchy.
Well, yeah, because I think with the smaller companies, there's kind of more room for input, whereas a bigger company probably has a lot of its methods set in stone. Where like a smaller firm maybe still does have things set in stone, and maybe they'll be resistant to change, but there's more room for like expanding, like I guess interpersonal relationships in that way. And like bigger companies, there's just too much. Like even if you're working for Amazon, for example, like you're not going to change anything about how that company runs because there's too many assets like involved, right?
Yeah. So like within an existing hierarchy, there's kind of a promotion pathway and kind of an existing culture of promotion that exists in a large company. You know, there's a regular review cycle. There's different, engineer 1, engineer 2, engineer 3, and people advance through these stages. And it's kind of more predictable than at a small company, where the companies that are small may be more agile. They can make changes, but and I would say that, like they may have, I put this under that bullet, but it's really like there's more variety. There's really a whole bunch of different cultures. So the culture can be I'll say cultures can be very different. And that means that they could maybe fit you very well, whereas the culture of a large company is kind of set by the existence of it and the number of people that work there. And so you're not going to sway that culture maybe as much as you could in a small company. A small company, they may have, oh, well, we take every afternoon off to go surfing, and then we come back and we work 8 to midnight every night. That's just our culture. So they have 2 kind of work shifts. There's various kinds of flavors of that. What are some other things? What else might be put under existing resources? I'm going to say, what was that? Technology? Yeah, so I would say technology and also facilities, right? It's very different to basically get a new car design off the ground if you don't have the existing resources to make cars. The whole process of making an automobile involves a lot of different things, a lot of different companies, suppliers, and other things. And if you're trying to start from scratch and get from zero to a car company, there's a lot of stuff that's going to come along with that. So an existing company may have, existing facilities. It might have the technology existing technology, the, equipment, analysis equipment. When you start to look at like the cost of a manufacturing facility, those numbers are astronomical by kind of our human standards as individuals. Other things that you can think of. So looking at my old notes, for example, you could have a relaxed culture. Kind of a 24/7 culture where, when I worked at Google in the mid 2000s, Google was still a relatively young company then, but it was, it's large, but it was a kind of 24/7 culture. They would give you breakfast, they would feed you lunch, they would feed you dinner. They would come pick up your clothes. They would bring a dentist to the office. Like you could almost go without having a house. I'm kind of kidding, but like the way that the support came with that, is essentially like they made they made it easy on people for people to keep working. And I, at that point I was already in my, let's see, yeah, I guess I was in my late 30s, 15 years ago. And so I was already kind of like, that was not as appealing of a culture to me because I had a family and I had other things. But as young people, it's pretty amazing to get, on campus, 6 different restaurants with awesome quality food. It was really cool. So, but it kind of has to fit you. So the cultures can vary. You can have a relaxed culture. You can have an intense culture. Here you can have a huge impact, right? It's possible to make a big impact. And for some people, that's really what they're looking for, right? They want to feel like they can really take something and accomplish something, however they measure that. Not that people in larger companies don't accomplish things, but within the scope of, what's happening at those companies, it's hard to imagine, kind of shifting things so dynamically, so drastically.
Like
What
when a
about,
janitor makes hot Cheetos.
is that
It
how it happens?
Yeah, it was a janitor who invented hot Cheetos because he was working for Cheetos, and that's how hot Cheetos came. So that definitely was a game changer for Cheetos.
Wow. It's interesting, and like, yeah, how things come about. What about like, in a big company, you have more job security generally? Right? They have the resources maybe to survive a recession. And here you have maybe like I would say like stock, like there's a better word for that. Did I write it down? Oh, here's what I wrote down. IPO payoff. Right. So in a small company, if you join and you're one of the, first 10 employees or something, you might have like a numerically significant ownership in the company. So, right, you can have significant ownership. So when we think of people, like a lot of the wealthy people that we think about in the tech industry, like your, Mark Zuckerberg or Sergey, like those, they became rich because their companies became valuable and they owned a lot of their company, right? So there's that possibility of actually maintaining ownership. you can still have ownership in the big companies, but you might have, 0.001% ownership rather than 1% ownership, or 5% or 10%, depending on when you start the company. So there's kind of like that potential for things to really go from just a small thing to something huge. You have benefits here. You probably have benefits here too. Meaning that you have health insurance, and you might have a 401k, some sort of retirement. So health, dental, retirement. You may not have a retirement program here, but maybe health. So one of the things you end up trading often for this kind of IPO payoff is that you'll end up taking a lower salary at a startup company than you would take at a large company, because you're expecting to, you're in on the deal, right? So the success of the company becomes part of your personal success. One of the benefits of these companies can be sort of the standard 9-to-5 schedule. And if not exactly 9-to-5, it's probably predictable, and it's probably about the same every day. And it probably, may or may not include weekend work. It kind of depends on the situation, but typically you have a more livable schedule. If you have a family, you have, other things going on in your life. Sometimes a big company can help with that. This might, sometimes relies on heroics. I remember when I worked at a software company, and they had bought a piece of software from another company, and after it was supposed to launch, it was like maybe 2 or 3 days away from being launched, and someone had discovered that the company that we had bought it from had copied some open source software, which, whatever, you're not supposed to do that. It was a problem. We had to fix it. But I had to basically rewrite all the 3D rendering mathematical stuff kind of in one binge of, like 42 hours straight of working without sleeping, because the deadline was there. And so all of that stuff had to like be rewritten, and it had to be written in sort of a, what we call it, kind of a clean room idea, where you're not using anyone else's code. You're starting from first principles of the mathematical transformations that allow, sort of, right? Like if you have a model of this and you're trying to rotate it in 3D space, there's a whole bunch of mathematics that go into like, how do you describe where all the pixels should be and what their colors should be? So you had to kind of rewrite all that math, but that required heroics, right? The project would not have happened unless, someone decided to step up and do that. So sometimes it's kind of required. The only other thing I'll add here is oftentimes you have worldwide companies. And that can often mean that you have opportunities for travel. So when I kind of got into, I was still mostly an R&D engineer, but I started to work a little bit in sort of this technical sales area. I got to travel to India. I got to go to Romania, St. Petersburg, Russia. And I guess those are the places I went professionally. And then while I was on those trips, I was able to extend them and then, stop and go see Paris and see other parts of Europe or other parts of those countries, because once your company has paid for the flights there, you can usually use your vacation to just extend them and do your own sightseeing, which is pretty cool. It's a pretty good, cool option. Um, my son in his first year, he worked at a large networking company that's worldwide. And his very first year of his job, he was sent to work in their office in Amsterdam for a couple of weeks to get to know that team. So that was a pretty awesome opportunity. So that's another cool thing, except probably not in COVID time. I'm assuming someday we will exit COVID time, but who knows? Okay, comments, questions, you know, even, just thoughts, like if you're questioning like where you might want to end up, what would be a better fit for you? Feel free to share those things.
I just had a thought.
Sure.
So it seems like for anything in engineering, I personally have so much math to do.
Yeah.
Because like right now I'm just in math 4, and it just seems like, because I also am in just a lot of in engineering, mechanical, materials, chemical, electrical. I know that sounds like a lot to undertake, and there's still a lot of overlap. So I don't really know what the one niche will be. I just think that there's going to be more than one, and it seems like it's just a lifelong journey that I'm kind of just like, I guess, surrendered to, if that makes any sense.
Yeah. Yeah, I can. And I think, so that is like a really big thing. And I'm thinking back to what Isadora was saying and something I've said in the past, which is, and things that have really worked for our students. So we're in weird times, right? And so it's, if you guys haven't been to the STEM Center when it is an actual place, a physical place you go, and part of the way that whole system works is that after you've learned a few things in college, like you've tackled your math classes, you've tackled, and I don't even mean all of them. I just mean as you move through them, as you're ahead of other students, you can take on a role of helping to teach those other students, right? So you're, like the tutors that we have in the STEM Center, the tutors that we have in the MLC, they were students, they are students, and they were students in the exact classes they're tutoring in not long ago. So the idea of an engineering degree, if you think about it, is this thing like, I can't do anything until I get this thing done. It seems really far away and frustrating. But if you recognize that every single thing you learn and everything that you do to kind of walk that path makes you a stronger candidate, gives you opportunities to have jobs within the field, that being a tutor teaching engineering students is already being in the engineering field, and that internships help you see that. And it just kind of, it takes away that goalpost idea where it's like you either get 0 or you score 6 points for going over the touchdown. And in a way, like every step should start, like try to find ways in your life that you recognize the value for the things that you've accomplished. And sometimes that is, reaching a little beyond where you're comfortable and trying to seek a job that, is in the tutoring centers or something like that. And then your other question about like the decision making and the breadth of everything, again, I wouldn't worry too much about that. Like in the undergraduate, like especially in lower division, so the classes that you take in Cabrillo, you'll be able to switch pretty much. Even if you have to maybe take another semester, if you wait all the way till the time you transfer and then you decide, I want to switch from being an electrical engineer to a civil engineer, because that's kind of a wide change, that's probably not going to cost you much more than a semester. So, leave your options open until you have to close them, if that makes any sense. So if your schedule allows you to kind of like say, these are my decision points, I have to make a real decision in a year and a half when I decide whether I take this class or that class, and just leave it open up until then and realize that every choice is ahead of you still. And you can choose between mechanical or electrical or what have you. I don't know if that, I don't know if that's satisfying for the question that you asked, because it seemed like it was just sort of that, I don't know. Let me just ask you, did that help at all? And if not, how might I clarify anything to maybe give you more insight into what you're wondering about? Are you out there, Clayton? Are you trying to speak? You're muted if you are. All right. Well, you're welcome to stop me at any time and ask a question. Let's just tackle one more little thing about the industries, and then we'll take a break. So the next thing we kind of want to talk about is sort of this difference between private companies, right? We already talked about companies in general, but there are all these private companies, and they can be big or small. But there's also the public sector. And the public sector would include things like, so over here, I'd have my big companies. I'd have my small companies, startups, etc. These are the things that you probably already kind of recognize as engineering companies. But within the public sector, you have things like county, building, and planning offices. And what do you think people do in the building county, the county build, I put ing in there, building and planning offices? What do you think they do?
Plan like roads and stuff.
Yeah, if they're kind of like all this, the kind of county infrastructure, right? So the roads, the bridges, the water, like the water and the sewer and all of that stuff, all the kind of those big engineering projects are basically managed. That oftentimes the private companies are contracted to do the work, but it's overseen by the county building and planning offices. And recognize that that job is a little bit different in Santa Cruz than it would be in San Francisco. And so if you go to a major city where they're building skyscrapers and stuff, like this is, a pretty sophisticated job where you're kind of interacting with the whole growth of the city. So there's these public sector jobs that also give you exposure to like a whole different kind of scale and class of engineering projects. There's companies like, or organizations like Caltrans, right? Caltrans is responsible for keeping all the highways kind of going, but they contract with companies like Granite Construction or Granite Rock to do a lot of the work, but they're the ones who are planning it, seeing how it all fits together, scheduling the maintenance of things, right? And if you think of all the hydroelectric dams, all the water projects, all of those are managed, and they're kind of huge engineering projects. So the public sector engineering thing kind of maybe disappears in the background because we don't always think about it, but it's a huge aspect of the engineering world. And it's where some of the largest kind of projects you could imagine at least get managed, if not accomplished. Again, like, you might, Caltrans is creating contracts for private companies that would pave or build an overpass or do that kind of stuff. But they're the ones who are originally kind of like getting the project up off the ground, managing it, and supervising it to make sure that it fits the specifications and codes of the county. So we'd have, water treatment, So you'd also have like sewage treatment. And so there's kind of there's options there as well. And those choices, you know, they give you different opportunities depending on like where you decide to work. You could also work in the public sector in education, right? In other words, my life as an engineer is very different now than it was when I worked in industry. It's just the structure is different, the pace is different, the motivations are different, the funding is different, the benefits are different. Like it's all kind of associated with that that public sector possibility of working. And we just don't want people to forget that, because sometimes that, I don't know, that can be a really interesting and amazing place for people that want to kind of see development and change at that kind of scale. Like, how do you change the overall infrastructure of a city to support a more sustainable transportation future? Well, that doesn't always happen by just working at a private company. You have to work within the structures where those decisions are made. All right, so let's take a little break. How about we'll take 11 minutes according to my clock, which would put us back together at 5:30. So I'm going to go ahead and pause the recording. Start recording. And we'll get started again. So let's go back and look at our agenda. Okay, so we did engineering employment, talked about the branches, functions, industry, and then kind of public, private, small and large kind of firms, engineering companies, professional and technical societies. You guys might have explored this a little bit when you were exploring the fields of engineering, but if you go to the web page, you'll see there's a link here to the engineering department's website. I'm going to bump that out so we have a kind of like easier list to look at. So this list is, if you kind of look through what's here, you'll see, okay, aerospace, environmental engineering, surveying, aeronautics. Like, so you go down the list, and there, a lot of these are built around sort of the different fields of engineering, right? So civil engineering, you see mechanical engineering, metallurgical, mining, and exploration. IEEE, that's the Institute of Electrical and Electronics Engineers. So essentially, these societies are groups that get together and kind of promote the industry, look for sort of setting standards in the industry, and for sharing information about the industry and how like how it kind of functions in today's society. And when we talk in a little while about ethics, we'll find that ethics is something that each of these professional societies tends to take a stand on. The other group of, the other kind of way that these societies are built are like by other kind of cultural connections. So you can see that there is a National Organization for Gay and Lesbian Scientists and Technical Professionals here. There's also the National Society of Black Engineers. There's the Society of Hispanic Professional Engineers, SHIP. And so sometimes the way that it cross-cuts the industry is a little different. So there's another, there's another kind of motivating force that gathers these people together and to try to forward some aspect of the engineering world, right? And to help kind of forward the engineering world. So this is these are really good options for that kind of networking that Isadora was talking about, which is you when you meet with the people from a technical society, they are almost by definition interested in expanding and having influence on people within the industry. That's kind of why they exist. So there's kind of a symbiotic relationship that can exist with a professional or a technical society. And almost all of these organizations will have meetings that you can attend as a student. You could have a student membership, and they encourage you to participate. So it's something that you definitely want to consider, like, you know, when you have on your resume that you're a member of, let's say, the Society of Hispanic Professional Engineers student club at Cabrillo, you know, that's gonna that has a significance. It has a meaning within the industry. And so, like I said, it could be more built around the kind of engineering that you're interested. It could be more about sort of the cultural aspects. They also, almost all of these societies would have scholarships, and scholarships that you may want to apply for. And it could help kind of get you moving towards building your professional identity, which is something that, you know, for some of you, it may be pretty easy to imagine how you move from or where you are, like, to your professional identity. And for some of you, that's might seem more mysterious, but a part of it is to start to participate and to not wait until you graduate to think that now this is when you get to join the engineering field. The sooner you try to join, the more likely you are to get things like internships, to get opportunities to work in companies for the summer, to get, you know, interviews, to get your resume spread around, to go through that whole process. So this is one avenue that you might explore to get exposure to the kind of profession of engineering. Any questions about technical societies? I really do encourage you to explore them, right? One of the messages of today is that it is what you decide to do with your free time that will help determine, like, how you function within the industry, how you function as an engineer. And just something to note. No questions out there? Let's check the chat. Chat looks good. Okay, let's go back. So and we'll revisit those in a second. Let's look at this statistics. So let's go back to the website, and I will go back to the module. And this first link, the BLS Outlook for Engineering Jobs, this is a really handy resource for understanding how the professions are kind of expected to evolve in the coming years. So in this list, you'll see this is for architecture and engineering occupations. You see, even at the very start, right, you have aerospace engineers as the second item, and the first item is aerospace engineering and operations technicians, right? So you can see the degree level difference that I talked about here, the associate's degree versus the bachelor's degree. And you can see a very significant difference in the median pay, right? So engineers do tend to make more than technicians, and that can vary from industry to industry, but it's something to at least understand exists, right? So you can see, you know, here's agricultural engineers and sort of their pay, biomedical, architects, chemical engineers, and other technicians, right? So civil engineering technicians, you see their median salaries around 53 versus 87 for civil engineers. You go through this, and, you know, so your first kind of pass through this, it's like, okay, there's a bunch of information here. It tells me something about the industry. It tells me about the pay. But let's say, okay, I want to know what's going to happen with engineers in the materials environment. So here we look for materials engineers, and we see sort of the range of the pay, the required degree. And if we look down here under job outlook, you see that it's expected to grow, right? And that during 2019, right, which is already in the past now, they kind of look at this information like in 10-year chunks. So it said that there were about 27,500 jobs in materials engineering, and that's expected to grow about 2%. And that equates to about 400 new jobs in that kind of period of time, right? So that 2%, it notes that it's slightly slower than average. So let's say I wanted to learn more about the job outlook. If you look at the tabs across the top here, you'll see there's one for job outlook, right? And if I click on that job outlook, you'll see that it gives me more detailed information about that, right? So it's saying materials engineering is looking to grow about 2%, whereas the total of all occupations and the total of all engineering fields is expected to grow about 4%. So it's not growing as fast as some other fields, but it's not shrinking either, right? And that's just something to take note of. So, it kind of gives you a little bit more detailed information. The other thing that's really cool about this is that if you go to the state and area data page, right? So that tab, and you have to drill down one more time and click on materials engineers here. It'll show you a map of basically where are most of those jobs? Like where do the materials engineering jobs exist? Doesn't want to let me scale it down. So I'm going to have to use keyboard control. So, that doesn't want to do anything either. All right, there we go. Try to get the whole state in there. I mean, the whole country. So you can see based on those, the color coding there, you kind of see that this engineering field is pretty widely distributed across the United States. So there's opportunities in a lot of states, but some states have more than others. If we go back a few steps, right? So I'll hit the back button, back again. I want to get back to my list. I guess I will just go ahead and click on the list rather than all the back buttons. Let's look at something that we think might be a little bit more location dependent. So like if I go to marine engineers and I go to state and area data, you'll see that for marine engineering, the jobs are more placed shockingly. I'm kidding, of course, with shockingly. They're more placed in states that have a border with the ocean, right? So that's where you're gonna have ports, that's where you're gonna have shipyards, that's where kind of the industry of shipping is going to exist on a state that has some sort of exposure to water. So if you're entering marine engineering, but hoping to live in Nebraska, that might not be a good combination. So you want to just kind of like keep that in mind. So there's a bunch of like information here telling you about, the jobs. Here's kind of a more table oriented way of discovering where the different jobs are. So you'll see, even though the color of these states looks the same, you'll see that it's really Virginia that has almost 4 times as many jobs in marine engineering than any other state. And that's because of the big shipyards that are there. All right, let's go back. Go back one step and get to the list. So again, like as you're exploring sort of job information, let's look for, I happen to know that if we go to nuclear engineers, you'll see that the job outlook for nuclear engineering, right, is a 13% decline as it's shown here, right? And if I go to job outlook, you'll see that there's a large expectation that there won't be as many nuclear engineering jobs as there were in the past. And, you can, they're kind of explaining some of that information here, like why that's happening, but it's something to note if you're interested in nuclear engineering, that it might be harder to find a job than in a different field of engineering. Okay. Any questions about this or how you might use this to kind of gather more information about the fields that you're interested and, you know, like where you might want to work and how those things are related?
Customize.
Okay, we'll do a little bit of a discussion on engineering licensing and graduate school. Those are two, you know, after you get your bachelor's degree or your, yeah, well, if you're following the engineering path, which is, you know, the possibility for some of you, we're going to kind of focus on that. This is an engineering course, and so we won't talk too much about the different pathways you might take if you were going into engineering
Sony and
tech.
will include a remote and apps for Apple TV, Netflix.
Okay, that's fine. I'm going to mute a few people here. I don't think they were intending that to get out. So I have a couple of slides, and again, these are shown or these are shared on the website. So if you want to take a look at them and click on the links and stuff, you can. But let's just talk at first, like, why do people consider getting registered as engineers? So the main reason is that, like doctors and lawyers and other kind of professions, engineering can greatly affect how the safety of people's lives. And, you know, so just like you wouldn't want a doctor that doesn't have qualifications to be performing surgery on you, you don't want an engineer that hasn't kind of shown those qualifications to build buildings or design buildings, right? So there's this whole aspect that it's protecting the public and ensures the quality of work. What it does for you personally is adds this kind of broader scope of responsibility. So when you are signing off a set of plans, you're essentially saying anything that goes wrong from here on out, I am like signing up to take responsibility for it. It doesn't mean that you're like at risk legally, although you could be if it was an intentional neglect to try to, you know, scam money out of someone or something. Like there's a difference between like things that happen, mistakes, designs, you know, like you can't control the world all the time. But part of being licensed is that, you know, you're basically insured with this trust or imbued with this trust, and you have to kind of follow through with it. For certain engineering fields like civil engineering, mechanical engineering, licensure becomes pretty important, and that's because of its aspects in building. So mechanical engineers are generally the engineers that design the air circulation systems in a building. And so that can have a very direct effect on people's health if the system is not designed to bring them enough oxygen to remove the CO2. You know, there's basically what is required to have healthy air. And if the engineers are not designing that properly, then you'll have an unhealthy building from the foundation. This just jumps out to a website that is centered around the kind of licensure process. And we'll jump out and watch a few videos there. I'm not going to, this link isn't active, so I'm not going to go to it from here. I do want to talk a little bit about like sort of the process. So, and this is why it becomes important even for you now, which is you have to get your degree from an ABET accredited program. If you don't start with that, you can't get licensed. So if you are in civil engineering and or pursuing mechanical engineering, and you think there's any possibility that you might want to get licensed so that you can sign off on plans and, you know, be the person that holds the responsibility, which, you know, like if you want to have a small civil engineering company in a small town or even in a big town, you know, you need someone at that company that can take the responsibility to actually get the job done, to get it's signed off with the state, and so you can move the building forward. So you want to really pay attention to that when you think about your transfer school. Beyond that, you're going to need to have experience working as a professional engineer, or working with professional engineers. And that's because in addition to taking these exams, which we'll talk a little bit, you need to have another professional engineer that will basically vouch for you, right? They have to basically say, I've worked with this person, I've seen them, they're upfront, they're straight shooters, they take responsibility for mistakes, they fix them, etc. Whatever it takes. It doesn't mean you're perfect. It means that you really exhibit the kind of integrity and ethical temperament to basically function as a professional within the industry. And that those engineers will, if they have questions about you, they won't like tie themselves to you professionally, right? Because that's part of what that vouching for one another does, is you say, okay, they have to pass these tests and all that, but I also vouch for them as a good person, a person of high integrity. And if they won't do that, then you're kind of blocked at that point. And that's good, because those are going to be the kinds of problems that develop if you don't have a kind of professional system or a licensure process. So in terms of the exam, there's two exams you have to take. There's one called the EIT, or I think it's now called the FE, the Fundamentals of Engineering exam. And that's the one typically people take right as they're coming out of school. And the reason is because that test is wide. It asks you to basically prove competence in all of the fields that you are all the courses and all the coursework that you've taken as an engineer. So it'd be, like depending on your field, that might be materials, it might be statics, dynamics, it's like the whole curriculum. And so when you come out of school is when your knowledge is widest. And as soon as you go into industry, it starts to get more narrow and focused. So you're deep in certain areas, but you've probably forgotten how to solve vibration problems if that hasn't been what you've done professionally. So that first exam, you definitely want to think about taking right as you leave school. And if you click on that link in the slides that you have, that will take you to, I think, a discussion basically around encouraging people to take this exam as soon as you leave school. The other exam, the PE exam, that one is specific to your field. And that's what the one you take after you've worked in the industry for a while and you've got kind of a sponsor in a professional engineer. And so those are two different kinds of tests. One is more broadly focused and the other one's more narrowly focused for the specialties that you're interested in. So civil engineering, if you want to do civil engineering in California, you also have to have kind of an awareness of the seismic design criteria. So there's there's a whole other test or field in which you'll have to get a license.
Can I ask a question about that
Of
last
course.
slide?
Yeah, of course. Let me go back to it.
Actually, it's not exactly about that, but it reminded me. So it says, get your bachelor's degree from an ABET accredited program. And then I started to think, so as Cabrillo doesn't offer bachelor degrees, how close can Cabrillo possibly get me to an engineering, Bachelor of Science degree before I should transfer to another, to a university that would?
Yeah, so we can get you basically halfway there. We can maybe get you a tiny bit over halfway, but essentially we cover the lower division and then you transfer. So, in the ideal world, that's 2 years at Cabrillo and 2 years at your destination college. In a practical reality, that could be 3 or 4 at Cabrillo and 2 or 3 at the destination college. It depends on, how much you're working, if you're a full-time student, if you have funding, if you have scholarships, there's a lot of factors that go into that. but Cabrillo can get you an AS in engineering, but we cannot provide you a BS. That said,
Yes.
there's nothing about Cabrillo that prevents you from getting your BS at an accredited university. The only or an accredited program, the only problem or the only like concern there is that to make sure that you transfer to one that is accredited. And yeah, so typically what happens is people will do whatever it takes, you know, because some people, not everyone's starting at the same place. Some people are starting in a different math environment. So they might have another year of math to get to the calculus series, but then that's kind of when they start the, you know, the march towards transfer. And like I said, it depends on how many units you're taking. It depends on how much you're working. It depends on whether you live with family or you live alone or, you know, all those dynamics. Do you have your own family? Are you raising kids? You know, like don't, but in terms of where we can get you about halfway. And, and that is played out by lots of our students who have gone through that exact process of basically doing their time at Cabrillo, transferring, and 2 years later, they have their degree. And the only other thing I would say there is that part of the transfer process is biased towards people that have more under their belt. So for example, if you've taken all the engineering courses at Cabrillo and done well in them, you have a better chance of getting a transfer to say Cal Poly than you would if you took a bunch of general ed, but hadn't taken statics and, you know, were still working on other things, because for them, it's more of a, they, you know, their transfer criteria involves how far you are in the program. So oftentimes you have a better chance of getting in if you're farther along. You know, and so that is a factor that sometimes plays into it, especially when you're trying for a competitive college or a competitive program.
So some universities offer engineering programs that are not ABET accredited, and you have to watch out for that, basically.
If you think you need to be working inside one of those professional licenses, like for instance, material scientists, they're not like, there may be a program to get licensed, but usually the way a material scientist is doing stuff is they're maybe working on a process, and then there's mechanical engineers that are designing the equipment that allow that process to happen. And then there's civil engineers that are involved in like building the facilities. So if you're, you know, depending on your field, it may or may not be like terribly important to have an ABET accredited program. Like I said, if you're in mechanical and want that possibility of working on, you know, kind of ducting and the air transport systems within buildings, then you definitely want to get into an ABET program. But if you're a mechanical engineer that's going to make, you know, quadcopters, that might not even be a good example, because those might eventually be regulated. But, you know, like engine parts or something like that, you probably don't need an accredited program because you don't need the licensure. So there's a little bit of gamble. And again, like it's more about entering it with knowledge than just, you know, like not knowing and find out after the fact, like, oh, I can't get licensed because I mistakenly went to a non-accredited civil engineering program. That's very different than like, I transferred to a mechatronics program that's brand new and hasn't been accredited. You know, that's part of the dynamics of an evolving industry. And it probably wouldn't have as much of an effect on you because no one's looking.
So in other words, it'd be really beneficial to have to like really solidify what you want to do as an engineer by the time you're about to leave Cabrillo.
Certainly on whether you go to an accredited program or not. And
like at least narrow down what kind of things you would want to do and whether it would require that or not.
Yeah, I would say
Yeah.
that's a good idea to have. And the truth is if you're going to a non-accredited program in a basic like civil engineering or something, there's I wonder what's going on there. It's probably like a brand new college or a brand new program, which doesn't mean it's not a bad thing, or it doesn't mean it is a bad thing. It's just they're, like it's so rare for those things to happen. It's usually the evolving engineering fields where you don't have accreditation. But there are colleges, you see Merced, right? UC Merced, when I went to school, didn't exist. It started more recently. Okay, other questions from this? So the main ideas here is that you kind of want to be, you don't have to know everything, but there are key points where if you miss taking the EIT or the Fundamentals of Engineering exam when you leave college, it's just going to mean you have to study that much harder if you have to take it after you've been in industry for 5 years, because the information's stale. It's not, it's not that you can't do it. It's just going to be a little harder. It's just going to require a little bit more focused training, and so you can do it, but it's just something to be aware of. This is sort of a repeat of the other slide. I kind of talked through these, right? So in terms of chronological order, the very first thing you would do is pass that first test, the engineering training or the Fundamentals of Engineering exam. Obviously, you want to choose an ABET accredited program. Then you also have to decide that you want to work with a registered engineer, because if you don't work with one, then you also can't get licensed. It doesn't matter if you've been in the industry for 5 years, 10 years, 20 years. If you haven't worked with someone else that is a licensed engineer, they can't vouch for you. And so you have to also pay attention and think through the next parts of your career. Like, I want to go work at a firm with a registered engineer. I know I'm going to have like 5 years working under someone, right? So you're not the boss, you're kind of like learning, and, so there's like, you're kind of planning this whole process of getting there, which is, just again, another thing to be aware of, not something to be afraid of or worry about, but just keep it in mind as you go through. Then you're gonna, when you actually have to take the PE exam, again, that's going to be after you've been out of school for a while. So you're probably going to want to, they have review courses, or they have kind of professional or, like manuals and things that practice tests. That's really what I'm looking for, like practice tests and study manuals, and lots of ways that you can prepare for the test. But it's not something you probably want to go in and just like, let's just see how it goes. Not because it's a problem. You can always go take it again, but there's costs and psychological costs and other things. You might as well be prepped for it. So when you go take it. Is there an accredited engineering tech program in Cabrillo? I don't know what their accreditation status is. There's certainly an engineering tech program at Cabrillo. I don't know how wide it is and how many different classes they offer. So I'll take a look at the catalog. I know that they offer a lot of software classes in eTech, but I don't know that they have a lot of skills classes, like, kind of the traditional bench top electronics using soldering and oscilloscopes and kind of the electronics program. I think that dissolved a few years ago, but I think there's still a lot of software classes that are taught. And there is definitely an eTech program, but it may or may not fit with exactly what you're looking for. Okay, so once you pass that exam, those 2 exams, you got your vouched, your registered engineer vouched for, then if you're in California, you have to kind of take these geotechnical and structural licenses to really to be an independent civil engineer in California. And I think that kind of wraps up the discussion. I didn't want to, there's no reason to spend too much time on this yet. It's just kind of a heads up, like things to keep in mind, like, okay, before I leave college, I remember there's something I may want to consider taking, and that's the Fundamentals of Engineering exam. Let's talk a little bit about graduate school. Are you guys, is my mic picking up my wife? She's also on a Zoom meeting, and I can close the door if it's kind of, if you're picking it up. Is anyone hearing it?
Nah.
Not really? Okay, thank you. So, you know, there's really, yeah, most of the time I'm talking so loud. Okay, that's good to know. So with a master's, you basically can have a couple of different types of master's programs. And a master's program is typically about 2 years. There are some programs, and I think one of our guest speakers a few weeks ago was talking about when she was at Cal Poly, she stuck around and got a 1 year's master's added on. She was the one that worked at Intel. Do you remember her talking? She did power systems for Intel. So typically you have a master's program. It's about 2 years. There's two kinds. There's sort of the extended bachelor's, the extended BS, which is, it's kind of like extra coursework, more focused coursework. So, you know, as you go through your engineering career, and even as a mechanical engineer, you'll already start to focus, you'll make choices about technical electives, you'll find kind of your niche, the thing you want to work in. So you're taking extra courses here, and maybe there's a kind of a final paper or a project. And then there's sort of a theoretical or a research program. So not, you know, exclusively, but this might be, you might find these at a UC type school, and these might be more at like the CSU type schools. So, you know, CSUs are not always like so focused on research, whereas a UC, like the teaching load for instructors there is basically saying, you know, we're not expecting you to teach full time. We're expecting you to run a lab, and then you teach in your kind of like, I don't know, anywhere between probably 20 and 50% is teaching, and the rest is running this lab. So with this, you also have coursework. But you're doing research, right? So you have research, and then you're writing a thesis. So, you know, you kind of have to know what you're interested in to know which one of these programs would fit you and what you want to accomplish with it. And as someone that went to grad school, I can assure you that it's very important to know why you went to grad school. And I laugh a little bit because I realize, like, I think I went to grad school because I was working already in that lab, and it was really easy to just transition. So I didn't even think about it as like, oh, I'm trying to accomplish a goal, or I'm like, I want to get done. I want to get my thesis done. I was like, no, I want to stay in this lab and work, you know, for the rest of my life. And at some point they're like, no, fly birdie, you have to go. But by then I, you know, finagled my way all the way to a PhD program. And so you know, if you're really focused on like, I want the master's for a very practical reason. What are some practical reasons you might want a master's degree?
Maybe to become a supervisor.
Some of it, I mean, I would say rather than supervisor, I would say that it's to have different professional opportunities. So, for example, to teach engineering at a community college, almost everyone has to have a master's degree or a professional license. Um, but that's, you know, like a supervisor is usually like more of an administrational position, and a lot of engineers that have bachelor's degree eventually in their career move up into management. So you climb from engineer 1 to 2 to 3 to like, you know, staff engineer to you know, whatever, VP of engineering, to maybe you enter the C-level class of a company. um, and that's open to basically everyone, that process. But there are certain kinds of jobs that are really that a master's degree opens to you. But one thing that it always is open, like opens for you, is the ability to negotiate for more money. And a lot of masters, you know, like a lot of companies will pay to send you to graduate school. They will, you know, they have their own vested interest in keeping you in the company, of, you know, all the time and money they've invested in you to keep you there. So they might pay for you to get a master's degree while you're still working there, and you just have to make a commitment to work there a few years longer.
Is there,
Yeah, go.
sorry, is there one that's actually better than the other? Like is going to UC or CSU actually better than the other? Or
They open
is it
they
just
open different doors, I would say. So like you're
or more hands-on stuff because they better all across the board? Yeah.
it's about your fit, right? So if you want to go into a research position where you're like, I start with a scratch, you know, I'm starting with scratch. I'm going into a lab with a bunch of stuff, and you know, like your goal is then to like find something to explore or do some research, do some, you know, some experiments, like propose how to do them and write this thesis. Like that whole process imp- like includes this idea that you want it. Whereas if you're just going and taking extra classes and kind of doing research in the sense of doing library research, that's very different than like having to get into a lab where you don't know if it's going to work, your experiments are going to work, you know. Um, I was one of those people, like I worked in the same lab as an undergraduate and then as a graduate student for a total of 8 years. So I saw a lot of students come and go, and like how it worked for some people and how it didn't work for other people. And also like how different professors behave. You know, my professor was very hands off. So, you know, you might have one monthly meeting with him, and he was always there to help if you asked for help and would always talk to you, but he didn't demand. Like he wasn't like your boss that's like, like, I don't know, that's on your back, like micromanaging you. He was like, you had to have self-motivation. And the people that weren't successful in my lab were the people that needed someone to nag them, or to, exhibit this kind of behavior of like keeping on them, like keeping them moving. And for me, I was like, wow, this is heaven, because for 3 days I decided I was stuck in my research. I couldn't get my experiments to work. So I went over to the library and looked up every guitar effect schematic from Guitar Player magazine, published from 1959 to, 1983 or whatever. Because you you have this freedom, this intellectual freedom to explore. And depending on your personality, that can either mean you'll never get anything done, or you will just kind of indulge it and find your way through, and you'll eventually get your thesis done. But that's not very helpful if you have kind of an agenda and you want to be in the workforce by this time and you want to achieve these goals. So it really has to fit your personality. Yeah, so like I'm just responding to Clayton's comment in the chat. So, you know, when electronics was more of a tinkerer's hobby, you know, that it was like you went to Radio Shack, which used to be this place that doesn't even exist, and you would buy the little components and you'd solder them together and you made your own distortion pedal. And they used to publish, there was a guy named Craig Anderton who published a column every single Guitar Player magazine about effects and electronics, and oftentimes they would give you these little schematics for it. I should go find that folder and put it up on Canvas for people, because
That
they're
would be
fun
awesome.
they're fun projects and they're real projects. You know, you're really starting with electronic components and soldering them together and like making effects. Yeah, I'll try to find that. But again, like back to graduate school, there were other labs where, you know, it's like if you weren't working on a Sunday night, like you'd get the call from the major professor going like, where the hell are you? It's 10 o'clock on Sunday night. Why aren't you at work? And like I would have shriveled in that environment. I would have hated it. I wouldn't have accomplished much at all, I don't think. Actually, I probably would have succeeded because I would have just said, okay, I have to do this to succeed, but I wouldn't have stuck around like I did. I would have gotten the hell out of there. It's kind
Wait,
of,
so you have to actually work as a grad student, like it's working for an education certificate instead of money? Is that what it means? Because I don't know. I'm kind of confused.
no, that's a really good question because I'm assuming that, well, so it costs money to go to school, right?
Mhm.
And so when you go in and do like a theoretical research program, probably you're working with a professor that has grant money from, you know, it could be a company. We had, you know, mechanical engineering professors that had grants with all the big car companies, like doing experimental stuff for car manufacturing and car, like the first hybrid car I ever heard about was this weird car that they built at UC Davis, you know. Um, but so you can get paid working in a lab. So when you are like a graduate student, you can get paid in two ways. You can get paid as a teaching assistant, which means you teach like undergraduate engineering labs, or you can get what's a research assistantship, and then you get paid to basically perform research. So, for example, the National Science Foundation may provide my major professor $500,000 of funding to do an exploratory research in the combustion synthesis of titanium nitrides. Like, I know that was like squawk, quack, 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 but I mean, you get a grant, you have a specific thing you're trying to explore, and then you make a relationship with those professors, and then they'll pay you to do that research. In these other programs, oftentimes you're paying to basically continue your schooling. So the research thing has a little bit of an interesting money dance in it because you are being compensated, you're being paid to do the research, and your major professor is an interested party because they have a commitment that they got with the grant to complete that research. So I don't want to make it seem like, but it's kind of like a job. The cool thing is though, like, I mean, that was one of the reasons they didn't get rid of me because, you know, when I transferred from Mountain Mike's Pizza making, I don't know at the time, what was even, I don't know, minimum wage might have been like $3.75 an hour or something, to like making $9.60 an hour as a researcher, as an undergraduate. I was like in heaven. I felt rich. And then by the time you get to be a grad student where they're paying you, you know, like compared to a real engineer, like nothing, but compared to, you know, a service employee, significantly. So I had a very comfortable life. I had, you know, my apartment. Um, and I left grad school basically without, I had a small amount of debt. I had about maybe, I think around $10,000 in loans at the end of my entire career, because when I started working in that lab as a junior, I was able to pay for my schooling and everything with the money I was making in that lab. So there are opportunities to essentially work as a graduate student. And so there's that symbiotic relationship where you're providing the research and the professor's providing the guidance and some other entity is providing the money. And those three things together mean that you're all kind of working together, but it does mean that there are goals. And if you're not able to achieve those goals, there can be problems, like the funding gets revoked, or he finds another graduate student that seems more capable than you, or, you know, but you can also have projects. And the thing about research is research doesn't always go well. Like it doesn't, then there's no requirement that the universe behave the way you wish it did, right? So research is usually exploring something that you don't already know. And so you're like, oh, well, based on these papers, I think it should, this should work. And then you find out that you were wrong. It didn't work, but that's still valuable, right? It's still good to know what doesn't work. So kind of one of the stories I always tell people coming out of this discussion of graduate school is that you don't have to be right to get your PhD. You have to be honest to get your PhD. So if your research didn't work out the way you thought and it provided you answers, or the answers that were provided indicated that your belief about the world was wrong, the honest thing to do is just say, here's what's really happening. And it doesn't matter what I thought was happening. Here's what's really happening. And so that is valuable because the next person doesn't have to find that out themselves. So one of the requirements in doing research is publishing it. And, you can go into the UC Davis libraries and find my bound thesis and dissertation, because that is sort of that academic relationship of no matter how it turned out, you just have to write a report about it, and you just have to be honest about what really happened. And that's just part of the game of being an engineer, is that sort of honesty, the intellectual honesty to say, this set of experiments told me something I didn't want to know, but I'm going to accept it as the truth, because the whole point of me designing the experiment was to find out if it's true or not. And I found out it isn't. So, okay, so be it. The universe won this one. I'll come back for another fight later. Any other questions about like this aspect of graduate school? And then, the other is sort of the PhD program. And PhD programs, they're typically around 5 years. And it could be like a master's +3, kind of depends on whether because a lot of people won't do what I did, which is, each degree you'll jump colleges and go to a new lab. I just happened to, fall in love with that lab and the kind of mad scientist nature of a materials lab. But so, if you're starting with a BS, it's probably going to take you 5 years to get a doctorate. And if you're starting with a master's, maybe 3. That's kind of the general rule of thumb. And then you have something called the preliminary exam. And this is kind of like the FE exam. And the FE exam, remember, is testing all of your undergraduate knowledge. So one of the things that can happen when you go to graduate school is, let's say that I got my graduate or my BS in mechanical engineering, and I worked in industry for 7 years. And during industry, I started to function in industry more as a material scientist, right? So I got involved in the materials aspect of something. And so when I go to graduate school, I want to get my degree not in mechanical engineering, but material science or materials engineering. And that's fine. You can do that, but you have to basically prove your competence in the field that you're stacking your degree on top of. So the preliminary exam, like the FE exam, basically tests all the undergraduate curriculum. And for Davis, when I was there were 2 days of written exams, like 2 8-hour days of written exams, and then like probably an hour, maybe 2 hours of oral exams. And all I can say is like that, I mean, like I actually look back at that with fondness because I did all the work to be successful. Like I spent months at home studying each subject, like going through and solving as many problems out of I could of every chapter. And, just like, it's kind of like if if you practice basketball, you practice it every day, you're excited to get into a big game and be able to have that opportunity to make a big shot. And that's how I felt about that exam. Like I was so excited about the whole process of learning everything that it was easy to study. It was fun to study. It was sort of frightening at the same time, but it turned out to be kind of a fun exam. So then you go through and you do this exam, then you do your research. And then you eventually get to what you call your qualifying exam. And the qualifying exam is where, I don't know, have you ever heard the term orals? This may be a term that, it's because it's a like 3-hour oral exam. So you come in there and there's 5 professors there and you're taking all your research, you've presented it to them, and they try to ask you hard questions and try to debunk your conclusions and try to find out if there's holes in your work or if you forgot to do a set of experiments or whatever, right? They're challenging you. And again, if you've done a good job, it's intimidating. There's no way it's not going to be intimidating. It's kind of scary. But at some point, if you just take your deep breath and say, well, this is what I know, this is what I don't know, and you don't walk out on the plank of making something up or guessing, and then they push you off because they watched you guess and then they decided to crush you. I mean, that's kind of the game, right? In these situations is, it's not about bluffing. It's really about what you know, what you don't know, what you thought about, what you forgot to think about, what you didn't know to think about, right? So there's a whole game in it. But after that, then you have to write your dissertation. And I think I actually, let me see if I have them. I guess I left them in my office, but I usually show people because it's, like, it's like something that I do hold a little bit of pride around is like, you got this thing. It's like a 300-page book and you wrote it, you went through, put all the information together, did all the charting, did all the graphing, got all the data, did all your references. It's all one complete thing and it lives beyond you. It's self-contained. And that's kind of one of the cool things about writing or like finishing a project is that then it's not inside your head anymore. It's out and it's done. It's something you can just be like, oh yeah, I did that. It's done. I don't have to continue it. But how do you write a 300-page paper? Well, you just keep going, you start with writing the first page. And you have to understand that this process is like 3 years long. So again, like sometimes your research is going well and you just churn out the experiments and you're getting all sorts of cool, like oh, it's confirming everything I had hoped to find in the universe. And then you're like cruising. And then sometimes your experiment, like your apparatus, the machinery breaks. And then you're like fighting all these problems with the machinery, and you haven't even done any research because the tool you need to do the research is broken. And that's another aspect of grad school is like, well, what are you going to do about it? And usually it comes down to you have to take the thing apart, figure out how it works, put it back together, fix it, da da da. You know, that's just part of the nature of the lab environment. There's you. There's you and there's no one else. So you got to kind of figure it out yourself. But that's part of the whole that's kind of the initiation. That's part of what it means to get the degree, is that you are capable of doing that. All right, I will stop reminiscing and ask if you have any questions. Okay. So let's kind of jump into this next thing, which is engineering ethics. And this will be the last thing we talk about tonight. And if it looks like, you know, we're not going to be on track to get the video watched and have you go through those quizzes. So I'll just extend those due dates. But like I said, by the end of this, you should have a little bit of time to kind of start watching that video and working through the assignment. So engineering ethics, you know, like why are we teaching engineering ethics to, you know, students just generally just starting their path down an engineering career? And I would say that the reason we're doing that is because the sooner you understand the kind of ethical requirements of engineering and see if you can kind of function within it, it's good, because like you either like are frustrated by it or you like it. And one of the reasons I kind of get to this, right? So there's this little joke here, which is, you know, this is a total engineer's joke right now, because a 34% cut in our corporate ethics should return us to profitability, right? And that's where, you know, engineers see that as funny because we don't have that opportunity. And that's part of the ethics of engineers come into conflict with the ethics of the other parts of the organization. So these are dictionary definitions of ethics. And I'm going to look at the second example, right? The principles of conduct governing an individual or group. So that's professional ethics. And that's the one we're going to focus on today. Because you can have personal ethics, you can have like all sorts of other ethical contexts, but the one we're really talking about is the professional one. And so remember ABET, right? So ABET requires that ethics be part of the curriculum. And that's one of the reasons that we talk about it in this class, and we talk about it in our engineering communications class, and you experience it basically as we go through the program. It's part of what we expect of students, the student code of conduct, you know, like how you get your answers to things, like, are you an ethical student? Like these things all mix together. The other thing is that, you know, it's required because engineers encounter these dilemmas, and the dilemmas, like I said, are often created by the different ethical constraints on the different people that make up a company. The other thing to realize is that values are not just instinctively absorbed, right? They're taught, right? It's like you have to understand the kind of assumptions that are operating within an environment, an engineering environment. And that, you know, to some degree just comes down to that. Like, it doesn't matter how many times you say, no, the experiment worked when I did it. Like, if the experiment only worked when you did it, then you give it up. Like, the experiment doesn't work. Like, the universe doesn't behave that way. That's not, you know, it's not about your power, your personal power, or anything else. It's about, oh, damn, physics doesn't work. And I've encountered that in my life where, you know, one experiment went really well, and the very next one that was supposed to be a duplicate of it didn't work at all. So what happened there? And of course, that's where the interesting stuff is. So you dig in and you find out all sorts of interesting things. The other thing here is that many things that are legal are not ethical. And, that's something to keep in mind. Like, laws don't define all the parameters of how we behave, right? They define a boundary where there can be consequences and sort of these defined consequences for going across those boundaries. And some ethical behaviors they don't actually are not up against a legal boundary. They're up against an ethical boundary. And you're going to have sort of the conflict of your personal ethics and your engineering ethics. And that, you'll see that manifest with your peers and your students and what their interests are and where they might want to work and the work that they might be wanting to do. And you may think like, well, that's not ethical to work in that kind of environment. And that may be your personal ethics versus your sort of professional ethics or your engineering ethics. So that's one of the reasons we go to those professional organizations, because they essentially make these decisions about what it is to be an ethical person worth working within that domain. So it's possible to have good personal ethics and poor business ethics, or vice versa. So let me ask you this, like, who is the CEO of a company ethically bound to?
It's workers ideally, as well as the people or the consumers or customers or public, whoever is supposedly benefiting from their product or their service.
Yeah. So in some sense, this is sort of the fiscal reality, or what they call the fiduciary responsibility of a CEO, is that they are bound to represent the interests of the shareholders, of the owners. And a lot of times in a good company, it also aligns with what's good for the owners is good for the workers, and what's good for the owners is good for the customers, but not always. And so that creates an interesting conflict, right? Just within that world. But then you throw engineers in there, and then who are lawyers bound to?
People they represent.
The people they represent, right? So they're clients. So when you're looking at like a lawyer that works for a company, they are like looking out for the company in terms of whether something is crossing a line of legality, not necessarily a line of like an ethical line. And so again, sometimes the lawyer, when the engineer and the CEO level, or there's kind of the management and engineering teams are in conflict about something, the lawyer will say, well, that's not illegal. There's nothing wrong with doing that. We believe we can defend that in court, that there's nothing illegal about that option, but there may be other consequences that go beyond the legal part. So that's kind of the interesting dynamic in a company. So they come from these professional societies. So let's go, let's just pick one. How about the Biomedical Engineering Society? And I'm really, truly just pick this one at random. Maybe, do they not have search? Really? That's no good. Let's see. All right, I'll go back to one I can trust. well, I can trust them all, but one that I know has one. How about, oh yeah, let's go here. So let's go here, codes and standards. At least they have a search function. Oh, but I can't spell. This is just an article. Take me back to the list. Oh my gosh. How could I be having so much trouble? It's the keyboard, naturally. Code of ethics. Oh my gosh, what a train wreck. Carl, how could you let this happen? All right, I'll go to ASEE. Let's see. All right, give up. You know you've lost. Someone I can trust. Where's the civil engineers? Ethics right there in a menu option, which was probably there. I just missed it. So here we have the code of ethics, right? So sorry for that weird detour, but if I spent more time, I'm sure I could find the ethics for the mechanical engineers. But the way a code of ethics works is that there's sort of these fundamental canons, and those are, there's kind of a hierarchy to these. And so it's like saying, these are the, you know, when it comes down to it, these are the 8 kind of most important ways to understand your ethical commitments. So this is, you know, not even a full sentence, right? It's just saying you have to hold the safety, hold safety paramount. And if we drill into that, we'll see that there's a whole sentence here, right? Engineers shall hold paramount the safety, health, and welfare of the public and shall strive to comply with the principles of sustainable development and the performance of the professional duties, right? So that it's kind of like fleshing it out so you have a better understanding of it. And it specifically calls out the public, right? So that's where, like in a company, the engineers in the company are basically saying, I have a commitment and an ethical commitment to the public not to let unsafe things out of our factory or out of our, you know, design teams, right? And so there may be reasons that financially, you know, the shareholders are not going to benefit from you delaying a project that's unsafe or for exposing a problem, right? There's sort of the conflict that comes with that. And that's part of why we teach it, is because it's naturally happens in those environments. It happens all the time. It doesn't mean everyone's in conflict or distressed by it, but it means that it's kind of set up that way. It's the checks and balances of ensuring that the public is safe, because the shareholders don't have that responsibility. The managers don't have that responsibility. They have the responsibility to the shareholders. So you have this responsibility as well. And when they come in conflict, you know, there are ways of resolving that don't go straight to being a whistleblower and testifying in Congress, right? There's like talking to your manager and saying, I'm concerned about this. It seems like there's a conflict. And then, you know, maybe the whole culture has already resolved it internally. And then they say, well, here's how we have come to understand the situation. And it does fit within the cult, like in this ethical code. beyond that, you'll see, right, A, B, C, D, E, F, like there's all of these more detailed examples or explanations of where this comes to bear. And so as you're trying to like get more nuanced into the ethical code, you kind of drill down to from the, you know, the bullet point explanation, hold safety paramount, to the single sentence that's in bold there, to kind of the whole kind of more structured and detailed explanations of what's going on there. Service with competence, that means, you know, like I, as a mechanical engineer and a material scientist, should not advertise my skills as an electrical engineer or take a position presenting myself as being competent in a field in which I'm not. Issue true statements. Again, you can drill down on that. You're bound to issue true statements. That that could be complicated, right? And so, you know, as you drill down to that, what does that really mean? Well, it's where that conflict can get involved, the kind of conflict of what do you think is happening versus what do you think is happening internally. So, you know, as you read down here, like, look at D. Engineers shall issue no statements, criticisms, or arguments on engineering matters which are inspired or paid for by interested parties unless they indicate on whose behalf the statements are made. So, you know, like this kind of engineers shouldn't use their professional status to try to discredit say another engineer or something along those lines. I was trying to think of a very specific example, but you like if you're doing like a kind of marketing relationship, you have to expose that as well. So you can go through these. I'm not, you know, like, actually I will kind of go through them. What does it mean to be as an act as a faithful agent? One way of thinking about that is that when you switch companies, you don't share the company secrets of your last employer with the new employer. You're supposed to basically hold those secrets and not act on them, pretend that you never knew it, right? So there's that whole part of not kind of breaking that. What does it mean to have reputation by merit? It basically means that you're responsible in how you compete for work, and that you don't misrepresent the scale of work that you've done. You know, if you've never actually done $1 million building design, then it's inappropriate and against your ethics, your own industry's ethics, to claim that you have, right? That's, you may think there's no, that it's a fair way of like of marketing like your differences or whatever, but you have to kind of like, you have to build it on your true merit or claiming the work of another, right? So anyway, there's that, the professional honor, right? That's kind of like, once an industry kind of gets tainted by a scandal or something, it can be really hard to pull your whole industry back out of that. I mean, no matter where you sit politically, like the way that there's the way that confusion is allowed to develop around COVID and what is safe and what isn't, and, you know, kind of the weird political dance that goes on where I don't want to get into the details of it, but at some point that is unhelpful in the long run for the medical industry and public health in general and medicine in general, if we can't agree on how to best handle things, like from a position of science, what is true and what is not true, and what does data support and what does it not support. The data supports that wearing masks works. It doesn't matter what you think. The data says that. It doesn't matter what human beings think. If robots did the studies, they would say, masks work for these humans. The aliens would say, oh, you know what? When these humans wear masks, they don't pass this disease to one another. It's not about how the humans think. So
But
that's,
within that,
yeah, go ahead.
sorry, but within that, wouldn't you say that it kind of depends on, you know, a lot of variables, like how you wear a mask and what kind of masks, like what are they made of, and if you even form it around your nose, for example, so you don't allow little air passages, you know what I mean? So it's like
Sure.
just wearing a mask is a really broad statement where it kind of depends on like if it's worn properly and if it's the right kind of mask. Like I feel like that is something that's kind of neglected. They're just like, wear a mask, you can walk in our store. If you don't, then you can't. But it's like, well, what if I'm just wearing a sock over my mouth and like it's made of wool and it's full of holes? Like that's not going to do anything. It's just performative. You know what I mean?
I do know what you mean. But the idea
Sorry.
that no,
Sorry.
it's totally cool. I mean, and it gets into like, I mean, it gets into the more nuanced, at least you're debating about like, what are the facts around that, right? So there's nothing about wearing a sock over your
Right.
mouth that
Yeah.
makes it worse than not wearing anything, right? We don't know of a mask, any way you think of a mask or talk about a mask, that takes the situation of not wearing something over your mouth and makes it worse, other than maybe you would violate the 6-foot rule or whatever. And all of this is not really, I'm just using it as an example where, because of that debate, there's sort of the debate over whether science even knows what's true or doesn't know what's true, or like what works or what isn't working. And that's why I say, like, as engineers, you basically accept that there is a material world that exists outside of the human beings, and it's defined by these rules and these behaviors, and it either your experiments prove out that it works or it doesn't work, you know. And there's a little bit of a like kind of acceptance there. But when engineers live in this tarnished area where it feels like you can't discern what is true and what isn't true, that's not helpful. Like, whether it's where we are or not, and whether it's because of doctors that misrepresented things, you know, it's like, it's hard to know even why it exists. But right now I can say that there's reasons that almost every human being is skeptical about what doctors tell them. And I'm not even saying that's right or wrong or justified or not, but it creates problems, because then when a so-called expert tells me something, I don't necessarily trust what that expert is telling me. And that can be problematic. And as engineers, we just have to acknowledge that we don't want to try to discredit other engineers, because in discrediting other engineers when it's not justified, we discredit our whole industry. But when engineers do bad things, like what Volkswagen did with the way they programmed those computers to, you know, like it's also bad for us not to acknowledge that and basically say that's an unethical act. Engineers should not have participated in that. I can understand why the business reasons behind it, but the engineers personally have an issue because they shouldn't have done that. So you're basically
You mean when they recalled the Jettas?
Well, just the whole idea of like, I understand that if I can detect that I'm being tested, I will change my behavior. I mean, anyone can think of that idea. The only thing that's going to prevent it is someone saying, yeah, but the whole point of like emissions control in the first place is that there's a connection between public health and pollution. And that is the justification for doing it. So that very first one, hold safety paramount, is the reason that that was problematic. And that's debatable. And I'm willing, you know, it's not like it's the professional societies and these boards of, you know, ethics and the professional societies. And what is it? Could you lose your professional license if you get caught up in one of these things? Yes, you could. Yeah, sure. Can happen. But again, you shouldn't be afraid of it. Like the whole point in like sharing this with you is that like all engineers experience this, and there are other engineers that have thought through how to like make these decisions. And you can go and, if you talk to your manager, you talk to your peers, and you talk to your manager's manager, and you get to this point where you're like, I need, does our company have an ethics officer? You can check with the ethics officer. You can kind of work your way up to see if anyone is willing to seriously consider your ethical concerns. And going to the professional society and basically saying, I need help on this issue is one of the options that you have as a professional. All right, I know we're very near the end of class, so let me just talk a little bit about the this movie. So it's called Gilbane Gold, and it's 24-ish minutes. I'm gonna turn it off, but it presents like an ethical dilemma where there's a lot of little facets to it. And it's funny because I watched this now, like, I don't know, probably 15 times, 20 times. I can't even remember. And I still watch it. And every time I watch it, I'm like, I find a new little thing where I'm like, oh, wow, that was interesting. Like, why did he suggest that? Because, when you're looking for like the ethical players or the non-ethical players in a kind of situation like this, it's always more complicated than you think, because the motivations of different people are guided by different principles and different ethical codes. So in any case, just watch this, and then, kind of go through the quiz. It asks you a few questions about like, what do you, like, where were examples of ethical behavior and non-ethical behavior? And, just take your best, your best effort at just trying to, oh, that's funny. In the suggested video, that's funny because in Engineering 10, we were showing, I think, a video like that. It was about your LinkedIn profile. Anyway, just go through these. So I'll extend those deadlines. The quizzes are pretty straightforward. They're not long. They're just trying to get at the real fundamental aspects of these ethical questions. And then the homework, it kind of asks you to go through this process, which is this kind of ethical decision-making process. And if we write down here, I'm not like, here's different links to these different cases. Read through them. Some are more interesting than others. Find the one that's most interesting to you. And there's this whole kind of process that's laid out here for making these ethical decisions. Right. And so we turn it into an engineering kind of process where you look at the problem, you generate, ideas, you brainstorm, you pick an idea, you build it, you test it, you see how it works, and then you repeat the process, right? So when you're encountering an ethical dilemma in this, as you read through those stories and they're presenting situations, you want to develop some options, and then you go through this set of tests. And the idea is that each of these tests is kind of based on a different philosophical, ethical philosophical position. So the very first one is, does it fit within the code of ethics of your profession, right? So that's what we were just looking at. Like, what is the ethical constraints of being a mechanical engineer? Then, kind of this utilitarian approach, which is which option will produce the most good and do the least harm? It's kind of like practical about it, like not getting like black or white about the thing. It's just like, well, of all my choices, this one actually seems like it does the most good and produces the least harm, and that may be good enough. There's this ability of looking at it from a rights perspective, like, are people's rights being violated? Common good. Is this overall helpful or not? This idea of virtues, benefits versus burdens, kind of, again, like being in the middle, where it's not like, oh, there's the one good choice and the one bad choice, it's like, well, maybe there's some place in the middle where there's a mix of good and bad, which makes on the overall makes it good. And then these things like the publicity test, like what would you do if a newspaper was published about, your participation in something? What if the roles were reversed? What if you were the one that was being adversely affected or exposed to these chemicals? Or, would you accept it? Like, or is it just because you're not subjected to that environment that you accept it? And then, that kind of getting down to that very last thing, which is more about this kind of legal thing. Like, can you defend this choice before a judge and a jury? Like, are you sure that a jury of your peers would actually even believe this was legal, let alone ethical, right? So there's this whole like list. And so the idea is that if you rank all your options against all these tests, and one of them fulfills and kind of like gets the thumbs up from 4 of them, where another one only gets it from 2 of them, like, does that hint at the way to get through something like this? So the idea of the assignment is to look at the look at the different case studies, look at one of the ethical codes, and then kind of try to find 3 different options, 3 different choices you can make, and then go through that test and like tell us which ones it passed, so maybe it passes 3 of them and fails 7 of them, or however you want to do it. And so you want to then use that process to figure out what action you should take. So again, it's just, it's kind of like you want to work within that process to maximize your points. Here's the rubric, right? So it's asking you very specifically things like, what is your description of the dilemma? What are the engineering canons that apply? You have to go look at the canons to know which canons apply, and then they have to actually apply. What are your 3 options? And then how did the test get applied, and how did they pass? And then what did you decide to do? All right. I think that we'll wrap it up for today. Like I said, I'll extend those due dates so you have until Monday night, and I'm happy to stick around and answer any questions or anything.
What exactly due tonight?
Nothing is due tonight. Well, I
Oh, okay.
thought I was going to have some time to let you work in class, but it just like our discussions went a little bit longer than I expected.
Mhm.
So nothing is due tonight. There are things that right now look like they're due tonight. Let me fix it so that
Okay.
it looks like they aren't due tonight before I even leave, just to be fair. So that is,
What do you think would be the best assignment to do first? Like if I were to do something tonight, and then because I have a lot of math homework too, and I just want to get as much done as I can. Maybe this
probably
one
like,
with the.
I would say the post-college options or the scavenger hunt, because that's going to just kind of like, you're just kind of looking for answers, and you take it at your pace and you go through the website,
Okay.
try to answer them. The Guilt Bane Gold thing, if you have a half hour to watch it and then take the quiz, it'll be easy. But let me make
Mhm.
sure to reset
Okay.
those deadlines right now. Wait, what class am I in? Ooh, I'm in the wrong class. Abort. I almost did it for the other section. Oh, Carl. Very ill-advised. Other questions? I'll stay on and do this, but I'll go ahead and stop the recording.